All right. So going through the lab here. This was lab number 3. Change the program so you have a 50% chance of getting hit. Add ability to specify player level, and then add a 4th attack. So let's change it so we have a 50% chance to get hit. So first off, we just need to find where he's attacking you. So it's right here. So before any of this stuff happens, you can get a dodge chance. And if you just do ran 2 and then set up an if statement, dodge chance, change. That means I didn't dodge, else. Like that. And you notice I use a little /T here to insert a tab that can push it over by 4 spaces, so it makes the output a little bit easier. You can also do this by 100 and it is greater than 50. So now half of my attacks will be dodged. So there I go. Keep dodging, and sometimes he still hits me. Okay. Second was to ask for player level. So player health right now is 10, or was 100 every time. So what I can do is, before this happens, I can get a player level, and I can say cout. Let's see in player level. And what I'm going to do is player health is now going to be equal to player level times 5. Same with monster level. What you can do is also I'm sorry, not monster level. What you can do is add a little bit of variance if you wanted to the monster health, because maybe you want him to have a little bit less health, but maybe he has a little bit more variance. I don't know. Maybe he gets up to 10 times the player HP, but he only gets a little bit of the player health. So this is how you get the player health equal to the player level that you typed in. And then I also asked you guys to scale the damage. I didn't really care specifically how you scale the damage, but one of the ways is that you take the damage that you base it on the player level. I really just wanted it to go up with player level, because otherwise the player level, the damage stays the same. So you could do that, where you add base level plus the player damage. You could also make the base damage scale up higher, like that. The formula you use is not really the critical thing here. It's really just, can you insert the player level into the damage calculation here? All right. Okay. And the final thing was ask for a sacrifice. So instead of, there's a move in Diablo 2 called sacrifice that the paladin used to have, and it would basically use your HP to deal damage, and it was unblockable, undodgeable, and it did 200-something% of like your damage. So it was huge, but it made you take damage based on your player health. So we just have to update some of these things to account for the new ability. And then the key was that this thing would take 10 damage off of you, or would subtract 10 health from you, but the monster was unable to dodge it. So the monster is dodging it right here. So if the monster choice is not equal to the player choice, then you'll deal damage. Otherwise, the monster laughs at your face because he's immune to the damage. So we just don't want either of these things to happen if I use sacrifice. So if my choice is equal to 4, which is the sacrifice choice, I want to do my logic here. Otherwise, you set up an else if statement, because out of these 3 cases, you only want one of these ever to happen at a time. So cout. Price your health for guaranteed flow. And then you can roll damage again. You could do the same thing. And this all works great, and you just have to subtract player health, right? Minus equal 10. But there's another way you could do this too. Like right now you see I have copied and pasted this code twice, and I can subtract player health. But I could just do this. I could just add that here in this condition up here. If monster choice is not equal to the player choice, means that if the monster, even if the monster is immune, if I pick player choice number 4, I just have to go in here. And then inside here, I can set up a very tiny if statement to say, hey, and the nice part about doing this, you only have 2 lines of code, like that. So I'm putting this if statement inside this other one. And the reason why that works, the reason why that works is this is going to let me go in here if I didn't pick the immunity, and this is going to let me go in here if I pick the sacrifice ability. So here's how I can set that up too. So now if I run this, I get myself level 100. The monster has 1,000 health, and I just deal damage. I dodge the monster's attack. So I'm actually doing enough damage where I'm able to kill him pretty quickly. Okay. All right. Need to. We'll do more like these little gamey things as we move forward too, because I think they're kind of fun to play with. But before that, let's jump into the lecture. All right, any questions on this, the lab? Okay, we're about to jump into functions. Before I jump into functions, I want to talk about why I'm talking about functions. Not only just because it's a big feature of C++. Up to this point, everything that we've been writing has been inside of a function called main. Only one function. Games aren't made inside one function. In fact, you can't have a game. You can try to make a game in one giant file. It tends to get a little out of hand, just like how if you were to try to put everything in a single folder on your computer, or like you ever try to organize stuff in like if you play a Minecraft or like a Fallout game or like a Terraria or anything that you have an inventory system and you don't have like a stash or like you just throw it all in one inventory, right? You have everything kind of strewn about everywhere. You have no organization. You have like your room at home, or you have like a backpack. You just throw shit in your car or whatever. There's no organization for anything. It can kind of work, but it tends to slow everything down because you can't find what you need, and things get to be a little cluttered. The same idea is here for C++. It's really hard to make a game with just one function because the strengths of C++ are the ability to remove duplicated work. One of the strengths is that you can write something once and then just reuse that the next time. You notice that I did some copying and pasting here, even here, right? I had to do it twice. It's not really a big deal that I do it twice, but the problem is I have to remember to update it in both places. And one of the strengths is that you can write little snippets that basically you can have do whatever lines of code you want. You can write something once and then call it over and over and over again to have it repeat that behavior for you. And that's what functions are going to let you do. So let's go into the lab here. Let's go into the lecture. See that? So here's an example. This is from the C++ primer book. So this is chapter 2 on the C++ primer book. We're actually going backwards a little bit because I skipped over functions initially. A function is a way to have some work happen and you don't necessarily have to know how to do it. So there's a function in C++ that called square root that returns the square root of a number. Does anyone here know how to calculate a square root by hand? You guys ever done it? Have you guys ever done that?
Yeah, but I just square root by hand.
Yeah, can you calculate square root by hand?
I haven't done that for years. I haven't done that in a while.
I don't think they ever taught me how to do a square root by hand.
64, you calculate square root of 60?
Yes, square root of 64 is 8. What's the square root of 65?
Oh, you mean like that?
Not
Oh.
What's the square root of 5?
It's like twos.
There's no real great way to do that. There's like a way to do it kind of quickly. So one of the cool things this is actually quite a complicated process to calculate square root. You should look it up on Wikipedia sometime. But like some of it, to do it by hand, you can kind of do rough estimates. Like, oh, well, 2 times 2 is 4, but 3 times 3 is 9. So I know it's between 2 and 3. So what's 2.5 times 2.5? That's like 4.25, not quite enough, right? And then you basically you kind of like zero in on where the square root is, and that's kind of one of the ways you can do it. John Carmack famously, when he wrote the original Quake, one of the things you have to do a lot is inverse square roots of things, because it's used in a lot of things like for calculating distances and comparing distances between two things. You need to do square roots to calculate distances because the square root. because this is from one thing to another. You guys remember Pythagorean theorem? Anyone know a squared plus b squared equals c squared?
Yeah.
But if you only know a and b and you want to find out c, you have to take the square root of a squared plus b squared. So John Carmack found a way to calculate the square root very, very quickly to a pretty accurate result. And ever since he did that back in 1997, there's been kind of that way that he's done it is kind of the way that we do square roots now. But the best part is that you can use functions to not care about any of that stuff. Yeah, you guys have a function, you have a button on your calculator, is probably in math class that lets you calculate the square root of a number, right? You just type in a number and hit the button. Every button on a calculator that does something is like a function call. Okay, every one of those things lets you do work on a number. So a calculator has a square root button. So this is an example where x is being set equal to the square root of a number. So there's a variable called x, which just happens to be a floating point number, and it sets equal to squirt, and then in parentheses 6.25. The expression squirt, which is square root here, it calls the square root function. So a square root function here expects an argument, which is the number that you pass in. So this is a very simple example. Let's go into another case here. Let's talk a little bit about how the square root actually works. Because what's crazy about functions is that they'll actually go off and do a bunch of work, and you don't necessarily know what's happened. So the value in parentheses here, that's 6.25, is information that is sent to that function. This is you telling the square root function, here's some information about what you need to know to do your work. Square root requires a number to actually do work. That 6.25 is being passed to the function. And when you pass a number like this to a function, that number is called a parameter. That 6.25 is a parameter to the square root function. A parameter is just a way to define information. You can have one or any number of parameters. Every function might have 0, 1, 2. You might have any number of those parameters that go to a single function. So what is the square root of 6.25? I think it's like 2.5. 6.25. Here's my function call. 2.5. I didn't know that. That's good to know. So when it figures out the answer to your call, it gives you back a number, and that number is called the return value. So what's crazy about this is that what it will actually do will be when you call this square root, it will take this and then kind of erase it and replace it with the value that's the answer. So it takes that square root 6.25 and essentially removes that and puts 2.5 there instead. Okay? So that function call kind of like it goes and does work, disappears, comes back, and says this is actually 2.5. So x will be equal to 2.5 here. Here's an example of the square root of 6 plus 25. So the numbers here indicate the order in which the function call works. Okay? So there's int main. Here's number 1. Runs some code. Gets this line over here. Says x is equal to the square root of 6 plus 25. Goes off somewhere and does some work. That number 2 here means that temporarily this arrow stops and goes all the way over here. The next line of code that it runs is all the way over here where the code is implemented. That's actually what the function call is doing. And here's where the code for how square root actually works. Number 3 is where it's doing some work. Nothing has happened over here. It's stopped. You can only ever have one thing going on at one time. So the program runs in top-down order. You only have one of those things occurring at one time until you get the multi-threading, which we won't ever get to, I don't think, in any of these courses. But this is only one operation you can run here, which goes into the code for square root. Now it's stuck in here. It's kind of like running around in here. It's kind of like a side dungeon almost. You ever do like side quests in the main storyline? Like trolling along, trying to get to the end of the game, and you get distracted because there's a side quest. So you go over here. Yeah. So you go call this function. It does some work. When it's done doing this work, it comes back to where it was called and replaces that function call with the answer that you were given. Okay. Does that make sense? So this ultimately is doing the magic work to calculate the square root, whatever that is. Finds out it's 2.5, shoves that back in here, and replaces this square root with 2.5. Right? Or whatever square root of 6 plus 25 is. Okay, so here's a breakdown of what you need to actually call a function. Okay, not all functions will return a value that you can plug into a variable. Keep that in mind. Not everything has to return a variable back. In this case, square root is going to give you an answer. There are functions which we're going to write that don't have to return something. So this is the variable that we're assigning it to. Right here is the name of the function we want to call. We have an opening parentheses and a closing parentheses, and then we have whatever parameters we need to pass in. In this case, we're passing in 6 plus 25, and then we put a semicolon at the end. Okay, this is how you call every function. Every function either has no parameters, or 1, or 2, or 3. If you have multiple parameters, you're going to separate them with commas, which we're going to get to. Okay? This is how you call functions. Okay. So that's great for calling them, but before it actually calls a function, C++ has to even know where that function is. It has to know how many arguments it takes, how many parameters it takes. It also has to know whether it returns a number or not. It has to know those things ahead of time. We're just calling it here. So we need a way to describe what a function looks like. So the description of what a function does, how many parameters it has, what it returns, you have to describe that. Either someone else has done it for you or you write it yourself, but C++ have to know that, and that's what's called a function prototype. So a prototype is basically, hey, I have a function here. This is what it takes as a parameter. This is what it returns, and here's the name of the function. That's it. That's pretty much all you have to do up front. Oh, let me go into the example here. Let's go into squirt. So here's an example of me calling the actual square root function. So I ask for the floor area in square feet. How fascinating. Oops. Okay, so I'm going to enter 1,500 square feet. Put a breakpoint here. So the square feet of my home is 38 point, probably looks like 38 feet by 38 feet, you know, side by side.
Question is, one story or two?
Yeah, you never know. That might be 17 square feet, 18, 19 square feet. Okay, so this is me creating a double variable that is assigned to the result of square root. What do you think happens if I put a breakpoint here? I jump into here. That thing is so defined that you don't even know, like the work that it's doing, it's not even defined like a header somewhere. I can't even tell what it's actually doing. But it is going off and doing some work. Square root is one of those things that has been optimized. Let's look at, just for example, I just want to show you guys a little bit of context here. This is pseudocode. This is basically one of the ways you can calculate square root. You literally write a loop that tries to do square root until it finds something that's close enough to the number that you want. That's how you do some of it. Here's the John Carmack. The fast inverse square root. This is the formula for the fast inverse square root. I like the comment here. And then it's a what the fuck number, and then you do one iteration, and then if you need to do a second iteration, you can. Okay. That magic number right there gives you a very close approximation to what square root is. It's actually a pretty.
You wrote it in hex.
Yeah,
Yeah.
wrote it in hex.
So approximately here here's one. So there's actually a gray line there, which is the real square root. And then there's the blue line, which is the approximate square root.
Quite close.
So C++
Very close.
Understand hex.
Yeah, for sure. Most, I mean, we use hex for a lot of things because it's a shorter way to represent that. Like that number here in decimal, because you can convert them here using a calculator too. If you have a hex number like that, you just convert it to decimal. That's that number.
I've never put it.
I wouldn't worry about it too much. Like we're gonna get into hex and stuff when we get into more. It's just a base 16 instead of base 10 numbers.
You do it on the computer calculator.
Yeah.
I always have hex and binary.
Let's talk a little bit about function variations here. As I mentioned before, sometimes you have to provide more than one piece of information. And this is also an example of a prototype that we're going to show. I'm going to show you exactly what it takes to write a prototype too. So if you have more than one piece of information, you need to separate them out with commas. So this is an example of us writing a function prototype. Remember I said a prototype describes the name, the return, if it returns a number, and how many parameters it takes, as well as what type of parameters it takes. And it goes in this order. This is what it returns. So a square root function will return also a double. Then you have the name of the function, and then inside parentheses you're going to describe the type of parameters you take. So example, to use this function, just like we use square root, we call the function by its name, and we send it two numbers separated by commas. This will take the power, this will take 5 and take it to the 5 to the 8th power and return you the answer and plug it into here. Okay. There are functions that don't take any arguments too. Here's an example of a function called rand, which you guys have been using a lot, which takes no arguments. You guys have actually been calling this already. It returns you an integer, it's called rand, and takes void as an argument. Void here is also optional. You don't have to put void. You can literally just put empty parentheses. This just means I have no arguments. Okay? You don't have to write void in there. It's kind of a personal taste thing. It just means that when you call it like here, just like what we've been calling it, when you call rand, you don't pass any parameters to it. Okay, so let's go over a more concrete example of a function prototype here. And we'll go into details about what it looks like. Here's an example of a program that creates one function called Simon. What does Simon return here? You see the word void in front of it? This is an example of a function that returns nothing. By the way, I'm going to have you guys write this, or write a version of this too very soon. Any questions so far on this? Am I losing anyone here? You guys?
I did this.
the way I did functions was it didn't call from anything. We made our own.
Yeah, just like this, you mean?
Yeah.
Functions are defined either ones that you write or the ones that are already defined in C++.
Yeah, we had to define all of ours, even if it was square.
Yeah. What do you mean you wrote the square root function?
I think so, yeah.
Really?
Well, not the square root. It was in Java, so
Well, so in C++, when you write a function, you have to declare what the function is ahead of time.
yeah.
Okay. This is the function prototype. You also describe how many arguments it takes, as well as what type of arguments it takes. And this stuff will be on the final. Keep that in mind. Here's main. Look what it's calling. It's calling Simon and passing in a number there. Notice it's not assigning that function value to anything. There's no variable that it's assigning it to. So it calls Simon here, does a cout, asks for a number, and it calls that function again with that number that you typed in. So here's what that program looks like running. So I'm going to type in a number, 1002. Doesn't seem that crazy impressive, but it prints out Simon says touch or shows 3 times, and then it prints out the same thing 1002 times. Let's step in here a little bit. Let me show you guys how it actually runs through this code. So there I am, my yellow arrow. It's about to call the function. Can anyone guess where that arrow is going to go to next?
Doesn't it have to read where Simon's coming from?
Yeah, where is that? If I step one time, what line number is it going to go to?
17.
17. Because it jumps in. Oops, I hit the wrong number. The yellow arrow is, it's basically on 17. It jumped to 18 because it doesn't need to run that. And it runs what's inside this function. Where does it go now? It's on 21 right now.
9.
It goes back to 8.
It actually goes back to 8. And then it runs 9. Remember, on the slide, it calls that function, does some work to the side quest, and then goes right back to where it was. It doesn't run that line again. It just goes back to where it was to continue running, in case there's more work to do on that line. And now it's going to go here. Okay, so now I'm going to ask for a number. So where is this going to go now? Where's that arrow going to go? Gabe. Where's that arrow going to go?
Back into 18.
Ask Gabe.
You're not Gabe.
Can you guess? Is it 18? All right. Okay, where's it going to go now?
What?
Oh, it's me now?
Yeah.
Oh, what was the question?
Where does the yellow arrow go? It's on line number 21 right now.
Wouldn't it go all the way back to the top?
Where? Give me a line number.
Oh,
Who said 13? That's
Yeah.
wrong too.
You're not Gabe.
wow.
Where's that yellow arrow go? It was on 12 before. I'm going to run this again for you. Okay, Gabe, where does this yellow arrow go?
Okay.
I'm on line number 8 right now. I'm calling a function called Simon.
Yeah. Wouldn't it go to the 17?
Correct?
That's fine.
Okay. Okay, I'm done with Simon. It prints out something. Yellow arrow's on 21. Where does it go now?
Back to time?
Back to where? Give me a line number.
12, because you don't need number 8.
Wait, 12? Here? Where was I just before I called that function?
8.
Right, so where do I go back to?
8.
Go back to
I
8.
thought it was 12.
Okay. Sorry, I'm picking on you, but you get to answer this next one too. Where does it go? Where's the line?
I'll learn.
Where's the arrow go?
Okay, it goes to Simon, call it again. It would go to 17, wouldn't it?
Correct. Okay. Goes to actually line 18, but it's close enough. Where does it go now? After it's done.
It would go back to 8.
Goes back to 8? Where was it? Just
Oh,
now.
wait, that was
How do you know it went back to 12?
12. Didn't it start there?
Yes, because it started there, right? Are you sure?
Don't confuse myself now.
12, right. Whenever you call a function, it goes off and does some work, and it comes right back to where it was before it called that function. Okay? Does that make sense?
Yeah. I just kind of forgot where the arrow kind of started.
All right. Let's do something more.
Are functions and classes different, or are they the same for C++?
They're different.
Different.
I mean, they're different in every programming language.
Okay, I just
Functions
want
are-
to make sure.
Classes use functions, but
Yeah, that's-
functions are separate.
Okay.
They're like a separate idea. You don't need to have classes to have functions. Okay. So let's break this down. This is the function prototype. This describes to me how I call this function. Again, here are the parts of prototype. This is a return. What does it return? Nothing. This is the name of the function, and this is the argument it takes. It takes one integer.
Damn son.
Okay.
So in the
Also-
declaration, you don't have to give the int a name like in
Nope.
the...
You don't have to.
Okay.
It's useful to, but you don't have to. I'm
Yeah,
going to go
I
into that.
didn't know that you didn't have to.
Because it returns nothing, you are not allowed to do that. Why?
Why?
Why am I not allowed to do that?
Oh, because you're not even.
What does it return? What does Simon return?
Turns that
No,
out.
it is return.
It returns void. That's what it says right here. This is the return.
Yeah.
The first thing in a function is the return type. So when it returns void, that means it returns nothing. Which means because it returns nothing, you can't assign that function value to choice. Let me give you another example here. Let's make a function that does return something. Let's keep this a little bit simpler here. Okay. So this Simon function I just changed to return us an integer and take no arguments. Which means I can put it into a variable. Okay, so where does it go? Where does that yellow arrow go? Okay. What line does it go to?
12.
Okay. I think you got it. Sorry, that was my mistake. You're right. 13.
Oh, 13.
Aha. Now we just get something that has a return statement on it. Where else have we seen return before? You guys have been using it the entire time.
52.
Yeah, it's like one right here. Return 0. You see that? And guess what? Doesn't this function look a lot like this function?
Yeah.
Guess what? Main is a function that's being called from you from somewhere else. You are the victim of someone else calling main function. You all thought that you guys were the ones that were starting your program, but that's not actually true. Main actually starts from somewhere else entirely. And someone's just calling a function called main on you. There's nothing really special about main. You're returning 0 here. So what does that mean, though? It means that you're telling the person that calls main, hey, the 0 is my result. So when I return 52 here, where does that yellow arrow go now? Remember, it goes. Where does it go back to?
9? Or, oh.
It goes back to where it was called. Line number 8. You had it right before you had this right. So it goes back to 8 afterwards. But what does that mean when it goes back to 8? Well, we're telling you that the result of this function is 52. This function gets replaced with the result that you returned. So when we say return, it means, hey, tell whoever's calling me this is the answer here. Okay? Which means when I go back to 8, this becomes 52. And choice now has 52 inside of it. Okay? Let's create a function called DoubleMe. This function has a prototype that takes one integer parameter. Okay, let's break this down a little bit more. Now I have a return type and I have a single parameter that takes an integer. Here's a trick too. You don't have to type in the variable name up here. Sometimes though, this is optional. You can type in a word there. This is because this is optional. I'm leaving it out in this example. Let's break down here. So there's two parts to every function. One is the prototype, and one is the actual implementation. Let's talk about how implementation works, because I just showed you guys how it gets called. But here's how you actually write what the function does. Because I told you you have to have a prototype. You can also call it a function header. They're kind of named the same. But here's what you have to do. There's 4 parts to a function that you just have to memorize. The first part is the return type here. The second part is the function name. The third part is the argument list, and the fourth part are any statements you want this function to do. So Simon, which was our previous example, here is the function. This is the return type, this is the name, here are the arguments, and here's all the stuff that Simon does. Because Simon has void as a return type, it means that that function doesn't produce a number. So that's why when you call it, you just put it on a line by itself and put a semicolon on there. You're also not allowed to assign it to a variable, just like what we said. So here, we just call the function directly, and it does some work. Okay. Let's go back to our example.
Real fast, Simon, the integer 3.
This one here.
Yeah. Why can't you just do, or I guess why is the 3 there?
Why is 3? What happens if I leave that out?
Yeah.
Well, this thing says you need to pass it
That's
one integer. No, you need to pass in one parameter, and it has to be an integer. This is not only telling you what type it is, this is also forcing you to pass in a number. By forcing you, I mean that if I try to compile this, it won't work. I'm sorry, I'm not compiling the right one. If I try to put this in here, see how there's a red squiggly there? It's telling me too few arguments in function call. That's the actual error. You have to pass it a number. That's the contract. You're requiring them to. Yeah. So
it doesn't matter what number?
in this case, it doesn't really matter what number it is. We can just do whatever.
So, okay, well, for what reason would you use a specific number?
Right, so this one, the reason why this is useful is because you can do this. Because I have one call here. 1, 2, 3, 4. I'm calling that function 5 times. What that function does is, I don't know, but I'm passing it a number, and that number is passed in as an argument here. So what happens when you pass in that number? I told you that you're required to pass in an integer. Whatever number you pass into that Simon function gets shoved into that variable called n. Okay? So that variable called n now has whatever number was passed into it. Kind of like how here, square root, you pass square root a number of what you want to find out, right? This thing has to somehow know what number he was passed in, because to do the square root call is based on what number you type in. Not every square root is the same. Right? Sometimes this will be 100, sometimes it'll be 3. This code needs to know what number you typed in. So in C++, when you write a function and you pass in one number, these are the 5 numbers, 5, 1, 5, 1. So this will be equal to 5, 1, 5. Let me just show you what that means here. This is just because the sample files are saved on a Mac. Okay. So 5151. We already know where that's going to go, right? It went into here. So n gets filled in with the number that was passed in. So if I actually show you guys this, n got filled out with 5151.
Will it always be 5151 since that's the first one it came to?
Well, let's see here. It's 5151 now. Let's go to the next function. I step in here. N becomes 14. That variable changes based on what was passed into it. And that variable only lives between these two lines here. As soon as these two lines are gone, that variable dies. It's cleaned up, not used anymore. Right? As soon as I go here and go outside that function back here, there's no variable called n that exists anymore. We came back. We basically did whatever side quests we needed to do, came back, and we've already turned it all in. It's gone, right? The materials we used for that side quest are gone.
Now, is it not calling it because it's void? Or
It's not calling it because it's void. Sorry, is that what you said?
yeah.
Well, it's calling it. The void just tells us what it returns. So look at these functions here. They're not actually. I can't do a variable like this, right? I can't do this. Why can't I do that? Because it's returning a void. Because it's saying that I don't actually have, this thing doesn't actually return any value. Look at this function down here. There's no return statement. There's nothing that says return 14 or anything like that, right? And in fact, that gives me an error because it's like, well, you can't return anything. You told me that you weren't going to return anything. Let's do another example here of the other function I had. Here's another example. DoubleMe. So this is not working. What we want to do is int this function is very similar to the Simon function, but notice it doesn't say void anymore, it says int out there. That means that now my function can do some work and return back the result. So watch what happens here. I'm going to put a breakpoint. So I know that I'm going to call this DoubleMe function, so it's going to go straight to line number 14. What is value here? What is this number here? What did I pass in? This is 12, right? So what is 12 times 2? It's 24. So when I say return, I say take this and replace whoever called me with that return value.
So if you wanted to display the value, you'd have to put it in,
Yeah,
in
let's.
the function.
If you don't have to. Yeah, if you want to do here, you mean?
Yeah, like you couldn't call the value somewhere else.
Right. You can't do it somewhere else. You have to do it inside the function. So here's an example. You'd have to do it like that. If you want to do it, you can do it like this. Oops. So So in here, 12 is passed as an argument to the DoubleMe function and is assigned to this variable name here. I could call this variable name whatever I want to. Cupcake. Cupcake is 12 to start. And it returns that value to be assigned to the integer up top. So let's do this. See out this value. What will actually print out to the screen here? 24. So I step once, prints out 24. Why is this? It seems like a lot of work for what seems like almost nothing I could just do there. Well, what if I just don't want to do that? What if I wanted to take result and call square root of result, and then result times equal to 15, result divided equal by 10.0, and result minus 5. All right. What do you think DoubleMe is going to return now? Who knows? 6? Apparently it's 6. But now I can do this. This is why functions are great. Oh, and here, let's print out what these things are. We know the first one's 6. Apparently the next one is 4. 10 is also 6. Maybe this is a formula for calculating how much experience you got for getting a kill. In Overwatch, we have a formula for calculating. You guys don't know what play the game is in Overwatch? It's this idea that when you're playing the game of Overwatch, the best 8-second kind of moment gets replayed to everyone in the game. So I wrote that, and the original formula for that is mostly based on your kills. There's also based on contribution to capturing points, assists. Some of this score that's being calculated is based on a lot of other factors. Like I scale score based on whether you got a headshot or not. Were you the last guy that got the hit? Did you knock someone off a ledge? Were you assisting someone? Were you capturing a point? Are you pushing a payload right now? Did you just die after you killed someone? Yeah.
Does that count, what you're talking about for Overwatch? Is that only for the top player, or is that for all?
Everyone gets a chance to get it. Everyone has a score. There's a function that's like, hey, get me the best score for this player. Give me the best time that they got in the match. That function might do a ton of work, and I don't necessarily know what it is. The nice part is that I don't have to care. If I only look at this program like this, if you just looked at this and we're like, oh, that's cool. That's a very simple program, right? I'm calling some functions and it's printing them out. But then you realize that, oh, there's actually a lot of stuff that's going on underneath. You don't necessarily know that up front, yeah.
All right, so as you talking about the playing the game, the best 8 seconds, right?
Yeah.
So how would you program it to rate it? To rate which is the best 8 seconds to actually show?
So every time that you do something that gives you some kind of event, like you killed a person or you captured a point or you push the payload, all that stuff gets added to a history of everything you did for that match. And then I figure out within an 8-second window, what is your best 8-second sample time in your entire match. Imagine like a little sliding little window throughout the entire match where I basically calculate the average of your score for that 8-second window throughout the entire match.
So did you write it that algorithm like that?
It's kind of the same idea. I mean, I'm not saying that this is a formula for playing the game. This is just, I don't know what this is. This is just me.
That's what I mean. Did you use functions with these integers to actually?
Like one of them is like, okay, I got to kill. How much of that person's health did he have when I killed him? Okay. So did he have 100% of his health? Did he have 1% of his health? Like if I just tap a dude, I just got a little bit of him. That's not really worth as much as me killing him from 100 down to 0. Okay. Did I get a headshot on that guy as part of the kill? Okay, if I did, then increase the score by a little bit. Did I knock him off a ledge? Okay, maybe increase the score a little bit more if I knock him off the ledge. Was I using a specific ability to kill him? Maybe bump it up, maybe lower it. So there's something that says, hey, give me the score I got. I passed it a kill. I say, here's a kill, and here's how much health the player had. Here's what I was doing at the time. Like a function like that might be get play game score, and maybe it takes health. Maybe it takes bool headshot, like that. There's a function prototype for get me to play the game score. I would pass in how much health I did for damage, whether it was a headshot or not, whether I knocked them off a ledge. And based off those, I could write that function to do things like this. Maybe it starts off at 0. Be plus equal to health times 2. And then if headshot times equal 0.5. If knocked off ledge. This is not actually what I wrote. This is just me giving an example of how you use it. Maybe I bump it up by that.
Is it illegal for you to show like a snippet of your code because you work for Blizzard?
We don't typically share code like that. No, it's not. Yeah, we're not allowed to like share it externally. So I'm writing like would be, I don't know, this is like totally fake and not actually close to what we do. But this is an example. Maybe you're writing, maybe you're making a first shooter. Maybe you just want to give a value for how much score you get for getting a kill. Right? Like in Call of Duty, they do that. Like every time you get a kill, you're like, are you on a streak? Destiny does this too. Like I got like a double kill, give an extra 50 points. I'm on a rampage, or I shut down that player because he was on a kill streak, give me some extra points. So when I say get play the game score and I pass in 100, it was a headshot and knocked off ledge. Let's see what it prints out, right? So what I would do, here's a good example. I passed in, I did 100%, 100 of his health, true, false. Okay. I killed 4 guys because I just ulted. This guy had 67 health. This guy had 10% health. This guy had 90% health. The first guy got a headshot. The second guy did not. The third guy I did not. This guy did not get a headshot, but I did knock him off a ledge. Okay. So I can print all 4 of those scores out. I'm calling that function 4 times. I don't have to write that code 4 times. I don't have to write the play the game score code 4 times. I wrote it once, right? And I'm printing it out. What if I want to add all those things up together instead of printing them out? Well, if I run this, so my play of the game score here was I got 300 for the first kill, 134, 20, and 225. So I got them all within the same time. So if I want to add them all up, okay. You can do that. My total score was, I didn't actually add it, plus. My total score is 679. The best part about this is that, okay, 679, well, I feel like headshots are getting tuned too high. So let me bump that down to a quarter. And let's bump this up to like 2 times. My score might go up or down based on my formula. So it's 679 before, now it's 764. Right? The best part is that I just change it down here. I didn't have to know anyone is calling it. I only had to write this code once. And whoever's calling it gets the benefit of that. Okay. That's where the power of functions go. This is what's called a black box. So let me just show you. Yeah, what's up, Dom?
And then I'm assuming you can use a function to call up to actually get those scores automatically, like the true, false, headshot.
Yeah, you could call other functions inside of a function. You can call any number of functions. Most of our game runs within other functions that run on top of each other. So this is a very simple example of calling one function. But yeah, you're right. I could be like, you just give me the player when they died, and I'll figure out whether they fell off a ledge, and I'll figure out whether they took a headshot. I'll figure out what hero they were playing as. Maybe the hero they were playing as counts towards play of the game score. So an example of that. So this is kind of an example of what's called black box programming. Black box programming is kind of like letting you write code so that you can work with other people, and they don't necessarily have to know how it all works internally. It's kind of like how you guys don't have to know how a car works to drive it. You just have to know that pressing the foot down and accelerator makes it go. You don't have to know how the actual throttle injects fuel or what the ratio of air to fuel mixture is. You don't have to know how your cell phone necessarily works on the internal. You just have to know how to turn it on and type in the password. A cell phone is kind of a black box in that you use it. You don't necessarily, if I ask you guys to make a cell phone from scratch, that might be incredibly hard because you don't necessarily know. Well, make a motherboard from scratch. Like a motherboard is a black box too. You don't have to know how a motherboard works to use it. You build a PC, you buy a laptop, it comes pre-assembled. I mean, you might understand that there's RAM and there's a CPU in there, but you don't necessarily know how all those things, like how the actual electricity goes through there. It's the same idea for functions. Someone will write a function for you that's really useful. You don't have to know how that function works to use it. If you ask someone like, hey, is there a function I can call that lets me know how fast this guy was moving when he died? I just need to know like how many meters per second he was moving when he died. Yeah, here, you call this function. That'll give you the right result. I'll be like, all right, cool. I'll call it, and it gives me the right result, and that's awesome. I can keep going. If you told me there's no function, I don't know where it is, or I don't think we've written one, then I would have to write that function, and now I would know how it works. Next time someone else goes in and they want to do the same thing, I just point it to the function, and they don't have to do all that work again. All right. I talked about a function with two arguments. I don't need to go over that, so let me do let me go over the lab. So I'm going to have you guys channel your inner Disney fan.
No.
I'm going to have you guys write a program that uses 3 functions. Main counts as 1, so you're going to write 2 new functions. Produces the following output. One function, which is called 4 times, should produce the frozen lyrics. Just let it go. And a random function called 1 should produce the line, can't hold it back anymore. The second part of this lab, if you don't get to this lab, you'll do it for homework. Write a program that asks for a player level between 1 to 100 and just prints out how much HP you have, okay, based on that. So you're going to write a function that takes 1 argument and prints out how much HP you have. It should be your level times 150. This is what the function prototype looks like. That goes at the very top of your CPP file. And your actual implementation, the stuff that your function does, goes on the bottom. Okay? So that's going to be lab. And I'll go over homework right now because we might as well we're here. So I'm giving you guys a file. This number 2 right here, if you can get to it, that's awesome. There's a part 2 for it. It seems like a lot of parts. I was trying to be descriptive, so don't be overwhelmed. I'm going to have you just write one function for your homework. It takes 4 arguments. I wrote the prototype for you already, so you just can take that and copy and paste that thing in C++. Inside the function, I want you to print out who wins that fight. Okay? You're going to give monster HPs for 2 monsters. You're also going to give strengths for both of those monsters. Inside the function, I just want you to print out who wins that fight. Okay? And winning that fight means whoever has more HP at the end. So basically, monster 1 attacks monster 2, and monster 2 attacks monster 1. Whoever has higher HP after that, you print out the winner. All right? And I want you to call this function 5 times. basically 5 different monster fights. It's just going to be exactly what I did for the play of the game score. So exactly like this, you're going to call something like this. You're going to call the function 5 times. And then, number 2, I consider making this extra credit. I want to see how well you guys can do this. What you guys just did today in the lab with simulating 2 fights, simulating a fighting of a monster, like basically you pick fights. The monster fight function can be changed to have them fight until one monster is dead. This function, number 1, is just, hey, just have them attack each other one time, just one attack each. Number 2 is make them attack each other until they die. Okay.
I was going to ask how you would link that, but I guess.
So I give you guys, so I'm giving you guys a example. This homework part 2 is basically the lab that we had. It's very similar to how we do this. The fight that we just did, the player fight that you guys did in class today, it's just that, except instead of a player fighting, it's 2 monsters fighting one another. So instead of a player choosing a number, it's the monsters attacking each other. It's actually a lot simpler than this too, because the monsters don't have any attacks. They literally just smack each other with their strength until they die. Yeah. All right. So do the lab. If you don't get to finish the lab, then do it for homework, and come in next week with week 9 homework. And next week I will have the review sheet for the final that we'll do on week 11. Questions? All right. So that's pretty much it for the class. Spend time